Hello everybody and welcome to today's video. We're going to be talking all about scheduling jobs using the IJobEntityBatch interface. Now, IJobEntityBatch is basically a level lower than entities.forEach, so it is going to require a little bit more setup, and it is a bit more complicated than the entities.forEach functions are, but it is going to give us some extra control over how we actually transform our data on the entities that we're iterating over. Now, I'll just say this at the top, most often we are still going to be using the entities.forEach functions, but the IJobEntityBatch jobs are a very fundamental concept that you really need to understand if you want to learn the inner workings of Unity ECS, as well as be able to maximize the performance you can get out of different situations that you may come across. So today I'm going to be going over what the IJobEntityBatch is, when you should use them, when you should avoid them, kind of the general steps of how to implement them, and then I'm actually going to show you how to implement them in the tutorial section of the video, where we're going to be creating this sample project that you see playing behind me. Now, I will say that this is more of like an intermediate topic as far as Unity ECS goes. So if you're not yet really familiar with multi-threading and jobs and how all that stuff works, I do have a couple videos on my channel where I talk about that. That's more of an introduction to these concepts that I would highly recommend that you watch before watching this if you're not yet familiar with how the C# job system works in Unity. So I'll leave a link to that up in the card as well as down in the description right below those like and subscribe buttons. Anyways, if you do have any questions on today's topic, or if you do have any suggestions for future videos, feel free to leave those down in the comment section below, or come join us over on Discord over at tmg.dev/discord. Now then, IJobEntityBatch. So first question, what is the IJobEntityBatch? So IJobEntityBatch is an interface that allows us to define jobs that iterate over batches of entities. This actually replaces the IJobChunk interface that would iterate over a full chunk of entities at a time. So of course, a chunk is basically a 16 kilobyte block of data that contains, a set of entities that all have the same archetype, which basically means they have the same components associated with them. And the IJobChunk interface basically allowed us to take one single chunk of these at a time, and then we can iterate through the entities on each of those chunks. So IJobEntityBatch, which we're going to be talking about today, is very similar to IJobChunk. Basically, the major difference is that we can actually break up a chunk into multiple batches, so we can actually process a chunk in smaller batches, which does make sense in certain scenarios, which we will talk about later in the video. The only other real difference is that there's also an IJobEntityBatch with index variant, and then with that, we can basically calculate a unique index for every entity that we're iterating across of, which again does help in some certain scenarios, which we will be talking about later. So when should we use them? Now, like I mentioned earlier, it is generally preferred that we use the entities.forEach functions. Of course, the entities.forEach functions are a lot simpler. There's not that much boilerplate code that we need to set up, especially compared to the IJobEntityBatch functions. And you'll see what I mean when we get to the tutorial section of the video. I mean, it's not really all that complicated, but it is quite a number of extra steps, and we need to make sure everything kind of lines up correctly, or else we could run into some weird situations in our code. So it's really only recommended that you use these whenever absolutely necessary, or if there are some cases where you may be getting a slight efficiency gain. Now, one kind of cool efficiency gain that you can actually do with these is you can actually check on each of the batches for the existence of optional components. So of course, because every single entity in a batch is going to have the same set of components on them, you can actually do just like a check at the beginning of the iteration on that chunk to see whether that chunk has that specific component. If it does, then you can perform some specific operations on the entities using that optional component parameter. Now, I would still recommend that all Unity ECS developers, at the very bare minimum, experiment with these so they kind of understand how they work, because it's going to give you a good sense of kind of what's going on under the hood when it comes to the entities.forEach functions and the whole C# job system and all that. And it also will help you understand your data a little bit better. Now, earlier I did mention that there is an IJobEntityBatch with index variant. So when should you use that over just the standard IJobEntityBatch? So basically, the only scenario that you would need this is when you need a unique index for every single entity that you're iterating across on your query. So maybe if you're storing results to a native array and you need a unique result on a per entity basis to be stored in that native array, then that's a case where you would use the with index variant. Now, this is in some ways similar to the entity inquiry index parameter that we see in the entities.forEach functions. We'll see that we'll use these when we're using parallel entity command buffers, and we need to pass in an index for the sort key. Now, the sort key is basically just something for the entity command buffer to kind of keep track of the order of operations to play back the different steps in. However, when we're using entity command buffers, we actually don't necessarily need to use the with index variant of the IJobEntityBatch. The reason is on all IJobEntityBatches, the with index and without index variants, they're going to have a parameter called the batch index. And so that basically is just an index for every single batch. And we can use that as the sort key parameter for our entity command buffers, and we don't necessarily need to go through the extra overhead of calculating the index of the entity. Now, this parameter is kind of interesting because it's actually going to be a constant number for every batch. So basically the way that it's calculated is if you take your entity query and then you basically line up all the entities in your query, and then you give them an index from 0 to however many the count is. And then, of course, you have that full list, and then you're going to break that up into the different batches. Basically, we just get the index of the first entity in the query. So this means that if we want to calculate the specific index of a given entity, when we're actually iterating through our entities inside of like a for loop or something like that, we'll have to take the index of that for loop and then add it to the index of the first entity parameter, so we can actually get the overall index of the entity. So basically this number just kind of says, where the start of the batch is, and then we basically have to, add in the exact index of where we are in the batch to find out where we are, in the overall picture of things. So again, only use the with index variant when you absolutely have to. Otherwise, just stick with the standard IJobEntityBatch because that's going to be more efficient. All right, so now I'm just going to quickly go through the steps of how to implement the IJobEntityBatch, just to give you an overview before we actually get into the tutorial section of the video, so you can kind of follow along about the theory of what we're doing. So the first thing that we're going to do is define the job struct. So here we'll kind of make the decision whether we're using the IJobEntityBatch or the IJobEntityBatch with index. The second step is going to be declaring the data the job will access, and we need to specify whether it's a read component or a read and write component. So there are 4 different types of basically data fields that we can have. The first is a component type handle. This is basically going to provide access to the entity data in the chunk. So this would be similar to like in the entities.forEach function when we're defining the component types kind of inside that query. This basically says, at some point we are going to be accessing this entity data. And so using this component type handle, we're actually going to be able to get an array of all the data, and then we can look up the data in that array. The second type of data field that we can have is a component data from entity or buffer from entity. This is basically we want to access data on entities other than the ones that we're iterating across. Go check out the video that I made recently where I go over getting data from other entities if you want to learn a little bit more about how this is set up. Of course, we can also have non-entity data fields. So this would be commonly used for like a delta time or just some other small variables that we may need that are not necessarily unique to any one entity. And then finally, we can define some output fields, and these are going to be like native arrays and things of that nature. And we actually need to get results from our jobs. Now, I'm not going to be going over how to actually implement these output fields in this video. That's a little bit out of the scope for this video. But if you are interested in something like that, maybe I can make a follow-on video where I go specifically into that because I think that could be actually a dedicated video on its own. So the third step is going to be to actually write the execute function. Inside the execute function, we're going to get the native array instances for the component data from the type handles, kind of like I mentioned earlier. Here's where we're also going to do any optional component checks on the batch. And if we do want to do anything, on a per batch basis, we would do that in here. And then lastly, we would actually iterate through the entities in the batch and perform any data transformations on these specific entities. So that's basically the setup for the job, but there are still a couple other things that we need to do to actually call the job. So the next step would be to actually query for the entities. So we're going to create an entity query. And it's best practice to actually cache this in a local variable so we're not, creating a new entity query every single frame, because most often we're going to be using the same entity query for the duration of the system. Also, we want to make sure that we're not including any optional components inside the query. We can kind of handle those cases inside the execute function when we do our checks for components. And then finally, the last thing that we need to do is to schedule the job. So of course we can do a run schedule or schedule parallel, very similar to an entities.forEach function. This is where we can also set our batch size. So if we do want to break up our chunk into multiple batches, we can set that here. Now, a couple things to note is we can actually only set the batch size when we're doing a schedule parallel. If we're using run or schedule, then no matter what, our batches are going to be the full chunk. So the batch size parameter is basically how many batches per chunk that we have. So a value of 1 means that there's one batch per one chunk. A value of 2 means that that chunk is now broken up into 2 batches. A value of 4 would be that chunk is broken up into 4 batches, and so on. So a value of 1 is going to be the most efficient because we're not, breaking up the chunk into multiple batches. But there are some cases where we may want to break up a chunk into smaller batches. One of the reasons that Unity gives is that, say that we have a small number of entities that are being processed by a very expensive execute function. In that sense, then yeah, maybe it makes sense to actually break up that chunk into multiple batches. However, if we are operating on a large number of entities, it doesn't really make sense to break it up into smaller batches because most of the worker threads are going to be used up already. So this would only be like, if we have some worker threads trying to process through a number of entities and we still have like a bunch of free worker threads open. All right, so let's get into the tutorial section of the video. You'll see that I have a very simple scene set up. We just have a plane and some capsules. And these capsules are basically broken up by color. So these blue ones are the ones that are just going to be kind of oscillating just at the normal speed here. And all these have is this oscillating magnitude data script with a value set to 1. And then the other ones are the green ones, which are the double speed capsules that have the same oscillate magnitude data authoring script just set to a value of 1. But it also does have the double speed tag authoring script. So then when we actually get into it, we're going to test for the existence of this double speed tag. If it has it, then we're basically going to double the frequency at which these capsules oscillate up and down. Now I will say that this tutorial video is not, the best way that we would actually implement something like this. There are a lot simpler ways to do this. But I figured that doing things this way for this specific topic is kind of the easiest way to explain how to use the IJobEntityBatch. It's maybe not the best use case for an IJobEntityBatch function, but it will give you the idea of how to actually implement it, and you can kind of translate that to your specific needs. Anyways, we'll move into our movement system. You'll see that this is just inheriting from system base here. I've set up an entity query and just have the blank onCreate and onUpdate functions right now. So we're actually going to skip over this movement system. So we're going to go outside the movement system, and here's where we're actually going to define the job struct. So of course this is going to be a public struct, which we can just call this the movement job. And this of course will implement the IJobEntityBatch. So if we wanted to implement the IJobEntityBatch with index, this is where we would specify it here. Of course, it's giving me this red line because I've not implemented the execute function. So we'll just go ahead and fix that warning, and we will come back to the execute function in just a moment. But we're going to set up our variables for our data before we actually do our execute function here. So here is where we're going to set up our component type handles. Now, if you remember, our component type handles are basically the data that we're going to be accessing on these specific entities. So first we need to think about what data we need access to on our entities. So the first one that we're going to need access to is the translation component, so we can actually move the entities up and down. So we'll make a public component type handle, and this can be just called the translation type handle. Now, because we did not specify any attributes on this particular component type handle, this means that it is open for read and write access. And this is actually the only one that we're going to need write access to. So the next component type handles, we can actually go ahead and put the read only attribute before them. So we'll just go ahead and create another public component type handle. This one's going to be for the oscillate magnitude data. We're just going to read in some data from that. Call it the magnitude type handle. Again, we're going to make another read-only public component type handle. In this one, we're going to be looking for the double speed tag, and we can just call this the double speed type handle. Now, one thing to note that this is one of the optional components because not all the entities that we're going to be iterating across have this component, but we still need the type handle because there are some that do have that component on them. And then finally, we're just going to go ahead and define some non-entity data. This is going to be the public float called current time, and this is basically just going to keep track of the elapsed time so we can properly calculate where the entity will go in the sine wave here. All right, so now that our data is set up, we can actually come down here to the execute function, and one thing that I'm going to do is I'm going to add the burst compile attribute to this function so we can take advantage of the burst compilation. So you'll see here in the execute function the parameters here. We have the archetype chunk batch in chunk, and so basically this is going to give us some access to some information about the chunk that we're iterating across. So here we can check, whether a specific component exists. It's also going to give us the number of entities in the specific chunk, so we know how many to iterate across of, things like that. It's also going to give us access to the native arrays, which contain the basically all the data components for the entities that we're iterating across. And then also we do have an integer variable for the batch index. Like I mentioned, we can use this for the sort key when we're passing in that we pass into the entity command buffers. So anyways, let's go ahead and actually implement our function here. So the first thing that I want to do is set up a frequency variable. So now we're going to set the frequency depending on if this chunk has the double speed tag on it. So the way that we can do that is by taking our batch in chunk, and we just do a .has, and then we can pass in here to see if it has the double speed type handle. So this basically means, do the entities in this chunk have the double speed tag? If they do, we're going to set frequency to 2, and if they do not, we'll just set frequency to 1. So next we'll actually get the data associated with the entities that we're iterating across of. So first we're going to get our translation array. So this will be equal to the batch in chunk dot get native array, and inside here we can pass in our translation type handle. And then so that's going to return a native array with all the translation components for all the entities in this particular batch. And we can do the same thing with the magnitude array, just setting this equal to the batch in chunk.getNativeArray, passing in the magnitude type handle. All right, so now that we have actually access to all the data that we need, now we can actually iterate across all the entities in the chunk and perform translations on this data. So we'll do that just with a for loop here. So of course we'll start at 0. We'll go up until the batch in chunk dot count. Of course, just increment that every iteration. Now we'll actually get the data on the entity that we're iterating across of. So first we'll want our magnitude value. We can just set this equal to our magnitude array at position I dot value. Next, we're going to want the translation. We'll just set this equal to our translation array at position I. Again, these are just going to be the data components for these specific entities that we're iterating across in the for loop, which is going to be the entities that we're iterating across of in the batch. So now we can actually go ahead and set our translation.value in the Y direction because we're just moving it up and down. So we'll set this equal to our magnitude value multiplied by math.sine, passing in our current time multiplied by the frequency, adding in our magnitude, adding in 1. And that will basically cause it to oscillate up and down. However, we actually just need to go ahead and set that variable back to the translation component. So we can say translation array at position I is equal to translation. And so now we have the job set up. It's going to, move these entities up and down. However, we actually need to create our entity query, schedule our job, everything like that. So we can just do that up in the on create. So there are a number of ways that we can create entity queries. This is the way that I've chosen to do it for this project. And I'm actually going to make another video in the future going more into detail on the different ways that we can create entity queries. But just take note of 3 things right now. Number 1 is that I'm caching the entity query to a local variable. That way I don't have to get it every single frame. Number 2, I'm specifying only the components that are needed. I'm not including any optional components. And then number 3, I'm specifying whether I need read or write access to a specific component. Now we'll actually just schedule the job inside the onUpdate function. First thing to do that is we'll actually just go ahead and create a var, call this movement job, set this equal to a new movement job. It's actually easiest just to use the object initializer syntax, where we can just, do these 2 brackets after here. So here's where we can actually set everything up. So for our translation type handle, set this equal to get component type handle. Of course, we'll just go ahead and pass in the translation, and then we're going to pass in the variable of false for is read only. So a couple things with this, you'll see that the get component type handle, this comes from the system base class here. You can also use the entity manager to do a .get component type handle if you're scheduling this job outside of a system base system. Of course, we want to specify the data component that we're actually going to be iterating across. And then lastly, we just need to pass in the is read only. It is false by default, but I think it is best practice to actually pass in false, just so we're really specifying that we do not require read only access to that. Next, we'll do the same for the magnitude type handle. Again, get component type handle, passing in the oscillating magnitude data. And here we're actually going to pass in true because we just need read access to that. And then we're going to do the same thing with the double speed type handle. We're gonna get the component type handle for the double speed tag. Again, this is just a tag, so we'll pass in true for is read only. And then finally, we'll pass in the time.elapsed time, and we will actually need to cast this to a float here. Okay, so that is basically us setting up all the public variables for the job, and we do actually need to do this every single frame, so it has a reference to the latest data for all these component type handles. Now finally, the last step of this, we just need to schedule the job. So of course there are multiple ways that we can do this. If we're just going to be running the job on the main thread, we can just do movement job.run, and then we just need to pass in the entity query here. Easy as that. Now, if we want to do a .schedule, we can actually do that and also pass in the dependency for the system, and we'll just go ahead and set the dependency of the system to the result of that. And then finally, if we did want to schedule it parallel, we could do a schedule parallel. The one thing that we need to remember to do is pass in a value for the batch size. So passing in a value of 1 is going to give us, again, 1 batch per chunk. If we did anything higher, it's going to break up that chunk into multiple batches. Again, using 1 is going to be the most efficient because it's going to be the maximum size. So we'll come back to Unity and see what's going on. So you'll see that the green ones, these are the ones with basically the double speed tag. You'll see that they're essentially moving twice as fast. They complete 2 cycles of this oscillation for every 1 cycle that the blue ones do. So you see that we're basically, again, making that calculation on the per batch basis rather than on a per entity basis. So it is, a little bit more efficient. Like I mentioned, again, this is not the most ideal way to get to this simple little result, but I do hope that, showing you how to use these in this simple context, really helps you understand how these IJobEntityBatch functions work, and you can kind of translate that into what you're working on and whatever you require for this. So anyways, that's going to be it for today's video. I really hope that you did enjoy it. If you did and you learned something, I'd really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos about Unity's entity component system and the data-oriented technology stack. Of course, if you do have any questions for me or suggestions for future videos, feel free to leave those down in the comments section below, or come join us over on Discord over at tmg.dev/discord. Hope you all have a fantastic rest of your day. I'll see you in the next one.